Hello children, welcome back to CK classes. So myself Punit CK. Today I came with a concept related to the right angle triangles, and this concept is important for a 10th standard. So you have an exam, so you have a lesson as this concept, and for the ninth standard children it was the key factor to learn something about an irrational number or irrationality of a number. So just if you observe, have drawn two right angle triangles with different what sizes. In the size 1, so it has different side units. You can say 5 units, 3 units and 4 units, different 3 sides. In the same thing, this case, so 13 units, 12 units and 5 units. So as we know that right angle triangle contains 3 sides, all 3 sides having some measures according to this diagram. So now, before I could go with my concept, I'm telling a single point, which is something called a longest side of a right angle triangle. Keep this one, longest side. Suppose if you observe the triangle 1 and triangle 2, if you observe triangle 1 carefully, you will come to know the 5 units, which meant this side is considered as the longest side. Here you could say 13 units, the side is considered as the longest side. So this longest side of a right angle triangle called as hypotenuse. So keep this in your mind. What is hypotenuse of a right angle triangle? The longest side of a triangle. So you can recognize the hypotenuse by using one more key factor. So this side is always opposite to the right angle. Suppose you can observe the right angle here. So the side is opposite to the right angle. The same thing here. So now let's get an idea about this right angle triangle. What it is actually. So observe the longest side. That I'll take this 5. So I'll take other 2 sides like 3 and 4. So I will try to write an equation by using some strategy. If I make this one, the 5 equals 3 and 4, it is mathematically not possible. If I write 5 is equal to 3 plus 4, even then the maths is not possible because 5 will never equal to 7. So now if I make a small arrangement just like this, watch, 5 square and 3 square and 4 square. There is a surprise. What is the surprise? The 5 square is 25, 3 square it could be 9, and 4 square it's 16. The 25 is equal to 25. So more it's balancing. So you can say my equation is working. So let's go for the second case. Same thing. I'll go for 30 units is equal to 12 plus 5. No, never. Cannot be happen because 13 will never equal to 17. What if I make it square? 13 square is equal to 12 square plus 5 square. Let's analyze. 13 square is 169 and 12 square 144 and 5 square is 25. Therefore 169 is equal to 144 plus 25 is 169. So if you observe in both the cases, the square of longest side is equal to sum of the squares of other 2 sides. So this was the relation was first identified by the man behind this trick was a Pythagoras. So in today's sessions, I'm going to tell you about Pythagoras theorem. What he actually tells us related to the right angle triangle. So keep this stuff in your mind, don't forget it. Something called longest side square is equal to sum of the squares of other 2 sides. So I can define this a formal definition. So in a right angled triangle, a square of hypotenuse is equal to sum of the squares of the other two sides. So this was a formal definition of what you can call a Pythagoras theorem. So I can define it. You can take it as a note. It is very important for your future classes. In a right angle triangle, there should be a right angle triangle 1. A square of hypotenuse is always equal to sum of the squares of other two sides. Just I will draw a right angle triangle for you for the small elaboration. So do you think it's a right angle triangle? So till I mention what the corner with the box, you can't conclude that as is a what? Right angle triangle. So now you can conclude yourself it's a right angle triangle. So now if you write this name or can say vertex name, this one is I call as A, and this point is B, and this point is C. So hope you predict the hypotenuse of this right angle triangle. So AC is the hypotenuse, length of AC. So that AC, so since angle B is equal to 90 degree, this condition is very important. So angle B should be in what? 90 degree. So then you could write according to Pythagoras as AC square is equal to AB square plus BC square. So take this as a note, don't forget it. So this was a definition or statement of Pythagoras theorem. This was a small elaboration related to the content. A right angle triangle is here, one of the angle is right angle, and angle B equals 90 degree. Then you can conclude that is a square of hypotenuse, that is AC square is equal to AB square plus BC square. As I mentioned earlier, so this concept is very important for 10th standard, even for 9th standards. So I told, so 9th standard children, you need to express some irrational numbers on the number line, and 10th standard is separately, you got a lesson there, so you can learn more about Pythagoras theorem in the further classes. So let's take one small, what I think it's not an idea, it's a small illustration of right angle, triangle. How does this work? Let me take a small right angle triangle. For my diagram purpose, I have taken a smaller one, it's the vertex. So now, so with the end of, I'll go for the other two sides first. You see, I know if I mark this is 190 degree. So now, if you watch closely, just say, oh look. So I can draw a square by using the two sides of a triangle. I can draw one more side, it's an approximate length. So you can draw one more side on hypotenuse. Now it's very easy to elaborate. Just I'll name this sides as this is A and this is B and this is C. So now you can observe the hypotenuse length as AC. I've drawn a square there. If I ask you to find area of the square, as you know, what area of a square is side into side. The length of AC I have taken this is side AC. Since I have drawn square, all sides will be equal. AC, AC, AC and AC. What is the side? That is side into, what is area? Side into side, that is AC into AC. You could write this as, this area as AC square. Similarly, let's come to this one. Length of AB So this could be the length of AB. Even this is AB, this is AB, this is AB. What is the area in this case? That is AB square. Go for third case. Even the small square BC there is, length of BC is BC, in all sides represents BC, then what is the area could be? That is BC square. So that's what the Pythagoras actually tells us. A square formed by using hypotenuse. A square formed by using other two sides. Then area of this should be equal to the areas of other two squares, AB square plus BC square. One important keynote, so this relation is valid only for the right angle triangles. You can't get the same relations for other triangles. That's what it is. Every Pythagorean concept, almost what they are related to the what? Right angle triangles. So now, what is the main use of this right angle triangle? So I'll take simple examples to elaborate. So this will be helpful for all the kids. So I'll take an example. Suppose I have a triangle. I'll take ABC itself because for your reference, I'll take an ABC. So I'll make it as a right angle triangle. I'm marking the box. So here I've taken AB is around 2 units. Length of BC is equal to 1 unit. What could be the length of AC? I know AB length will be 2 units and BC length will be 1 unit. And what is the length of AC I could calculate it? So since it's a right angle triangle, you can find unknown side of a right angle triangle by using Pythagoras theorem. That's what this is the main application of right angle triangle. Let's do it. Since this condition is important, angle B is equal to 90 degree. Okay, now we can go for the Pythagoras theorem. So this implies, so since angle B goes 90 degree, so this implies you can generate a relation by using Pythagoras theorem as AC square is equal to AB square plus BC square. So what units or what the measurement that given, you put it in here. So AC square, I need to calculate AB square, that is 2 square, BC square, it's 1 square, the 2 square is 4 plus 1 square is 1, that could be equal to 5. So now bring down AC, but you need what? AC in nature, but it is square there is. You can get rid of this square by using what? By taking square root of them. Now take square root on both sides. So this is square and square root is going to cancel. So at last what remains? That is AC is equal to root 5 units. Okay, I can modify, I can check this what question mark, I'll put here root 5. So now I told, so 9th standard kids, you should be learning about the Pythagoras theorem for your irrationality of a number. Watch it closely. If you take 2 units here, if you take 1 unit there, you are getting root 5, which is irrational in nature. Do you think root 5 is irrational? Yes, root 5 is irrational, no doubt about it. So now root 5, the length, if you want to get root 5 length, you just construct some right angle triangle, that will help you to represents some irrational numbers on a number line. So in my next concept, in my next video, I will tell you how to represent irrational numbers on the number line and also some properties of irrational numbers. Thank you. Stay home, stay safe. And one thing, so please inform about this channel for your friends and relatives for more learning videos, and please don't forget to subscribe for best and better videos. Thank you.